Hey guys, so a quick video to show how to use the Lunchbox SpaceTruss components with the new Rhino 7 SubD Multipipe components. Now what you'll see that I have here is a setup that's basically kind of two rail curves that I modeled with two cross-section curves that I'm just going to use to do a very simple sweep to surface. This can be any surface of any type that you kind of come up with, right? But I'm just using this as a example. So first rail, second rail, and then the cross-section curves, enter, to get a surface like that, right? Um, and I'm sort of assuming this is, maybe a sort of canopy condition, although it could be a vertical or a wall condition as well, or a combination of both. So we're just linking this in. And this component, the SpaceTruss 1, is coming from Lunchbox under the structures. And these methods generally will work for many of these, right? Some of these 2D patterns as well, or any kind of subdivision logic that gives you kind of edge curves that come up like this, right? So the space structure 1, and we'll look at 2 down here here in a little bit, but it's basically these two guys, 1 and 2. So the surface comes in and automatically you get, of course, I kind of tweaked the numbers here a little bit, but these are just simple UV subdivision sliders. So 16 and 7, right? Generally we kind of tweak these numbers to get a more, right, logical kind of proportional distribution of these things. So you can kind of figure out, what looks right to you at the moment. And then a very simple kind of third parameter that deals with the truss depth, which is the offset, right? So you can make it deeper, right, or shallower. If you go into the negative, then it goes in the other direction, right? So this can be like that. So your surface on top, the truss is below, and then you put, let's say, columns to support the truss, right, for example, right? So this is kind of very simple, easy, straightforward. You'll see that depending on how your surface is modeled, mine was a sweep, right? So, the sort of proportion, right, of the subdivisions changes with the iso curves of the surface. So if you need it to be more even, then you have to model in a way so like it gets more evened out, or rebuild it, things like that, right? So that's very simple. I just maybe want to point out here, and I'll reverse it just so it's easier to see, is that in the outputs, right, it gives you nodes, which are kind of node points, lines A, B, and web. So A is like in this case, right, the original surface, right, the grid that is on the original surface. B is the top grid, right, which are kind of the offsets. And then webs are the webs of the trusses that are spanning in between. And you'll see this particular, truss is a 3D truss, right, that it's kind of going in between, right, diagonally in both directions, both in X and Y simultaneously, right? So this is the kind of truss that it is, so it curves inwards, right? So yeah, that's kind of very simple. Now, just a couple of things to kind of maybe try out before I get to the SubD multiple is that, if you kind of look at the original, let's say, and let me reverse this again so we can see it a bit better from top. If you look at the original subdivision of this, and you can actually mix and match these with other, right, surface subdivision logics. Again, right, if I'm kind of pulling from the Lunchbox kind of component, like you get anything that's on a sort of quad grid, right, could actually be used for this. I think, for example, triangle panels A or triangle panel C, these are on like quad grids, right? So these would actually work pretty well with it as well. Some of the diamond panels might actually work with it as well. Just an example, if I pull in a tri A, I'll just link in the surface here, right? And I'll replicate the same UV subdivision. So these are the same, right? Coming from here, oops, wrong input. Coming from here and here. Right, so these panels will actually overlap and match it, right? And it's maybe kind of hard to see, but you do see that it is working exactly with the same, right, UV subdivisions. If I just really quickly scale them, so you can see them a little bit better. Normal scale, let's say pop in an area. So going from here to here, using the area centroids as the scaling center, and then using the panels to scale the geometry. this factor is kind of set to 0.5. But what we'll see is that these panels, right, the scaled panels, which we can use to cut out or whatever, right, to Boolean out or do a cutout, make these into perforations or things like that, actually inherently already work within the same logic, right, of the truss, right? So in those cases where you can kind of find synergies between a surface subdivision logic and the sort of truss logics, then it makes the kind of two systems work really well together, right? And obviously you can take this and apply a tractor or something like that. So the opening can vary right across the entire thing, right? So you start to kind of put bits and pieces of these logics together, okay? Now, the multi-pipe portion, if you just double click and search, you'll find the multi-pipe here, right? And it's actually very literally, you just give it curves, right? And I have a kind of really quick example over here, which I will link in, or let me clear values. Do that. And disconnect. So if I take these and set these curves in, link them in, you'll see, essentially, right, the multi-pipe components does a sort of merged SubD multi-pipe, not the normal Rhino pipes, right? A lot of the parameters are kind of down here, so if I put this in, I do suggest kind of testing this out for yourself, just so you start to kind of understand what some of these things are, like the node size kind of controls like the overall, right, node thickness and the connection points. This can be bigger. The strut size can make things skinnier, right, in the portions where it's not a node, but it's more like a longer, pipe section. You can control that. The end offset softens the corners and, makes the nodes kind of bigger. That's where you're interested. Segments is kind of not something you would necessarily play with in here, but if you are eventually going to modify this in SubD eventually, then how many segments this has determines how much editability it has, right? But you can always add these sort of after the fact, right? So this just kind of shows you what some of those basic main parameters are, right? So going back to this, what we can do, right, is, as you can imagine, right, and generally you want these, you're going to want these to be fairly clean, or like these curve networks to be fairly clean, meaning that you want to avoid, you probably want to clean out any curves that are overlapping, right, and they should kind of meet at corners, right, to make things, or meet at, nodes or vertices cleanly, so they will process better. Like if things kind of overshoot or whatever, then it may not work as well. But we can take these curves that were coming from, right, our truss and put those in, right? So I have kind of 3 different segments. You can do them separately, but then they would be kind of 3 separate entities, and like these will not merge, right? So to merge them, you can literally use the merge component. First input, second input, and third will also automatically pop up, right? And I'll get a fourth automatically, but I can, use, if I zoom in enough, I can use these plus minus signs to add or decrease the number of inputs, which is true for many Grasshopper components. So these, like if I highlight it, is essentially the entire truss, right, curve network. And I can put these into here. And what you'll see is that I'll get a SubD version, right, of that. Now, I think, right, it's a little maybe too thick at the moment, right? So we'll bump down the node size. Now, this is going to be a little bit heavier, right? So I would kind of try just like doing inputs as opposed to sliding it. So 0.25, maybe 0.3, right? And then the strut size, we can probably start to beef that up a little bit just to kind of get the proportions a little bit better, change the offset to something smaller so I don't get too bulbous, right, ends or corners, so you'll get something like that, right? So this is an even offset, right? Like, so the truss is a sort of even offset. You can kind of take the multi-pipe component and bake it. Say, okay, I can click it and drag it to the side. So you'll get a sense of what we're looking at over here, just as long as it doesn't collide. Now you will see, like, depending on your overall geometry, there might be portions depending on the calculation, like some of these nodes or struts get a lot bigger. So that's why, like in this case, you might need to or want to kind of go more into the SubD modeling side of things to kind of pick some of those nodes and, you know, pull them smaller, right, and everything else. That is something we'll kind of cover maybe in a different portion, but you know, for these, like, you kind of get pretty nice, clean, interconnected wire or, like, you know, pipe networks, right? So that's kind of, you know, one example, right? That's for SpaceTruss 1, right? And you can see the cladding example. Okay, so I'm going to hide, turn most of those off, and come over here. Now over here, what I have is the exact same surface that we had before, right? Nothing, you know, completely different, except if you look at SpaceTruss 2, what it uses is two surfaces, like instead of an offset, right? This is a distance offset that's calculated off of the initial input surface. This one actually uses two surfaces as to kind of decide, right, how to draw the trusses. Everything else is the same. So what I did was actually I just kind of, you know, took the same surface, copied the edge curves up, and just modified them a little bit, right? So they're slightly wider. There's a sort of thicker portion here, narrow portion there. Just mess with the control points a little bit, and actually I added a middle, right, cross-section curve that is like this, bulbing upwards, right, to basically kind of get a little bit of thickness. So again, like, I'll just sweep to the surface, first, second, 1, 2, and 3, right? So I'll get an input surface that's doing this, right? And this is actually to show you that, okay, with this method, you can control the thickness of the offset more precisely. So first surface, right click, set 1, the bottom one. Second surface, right click, set 1, which is the top one. And these are basically identical to what's above, right? Nothing too fancy. So what you'll see is that, like, we basically get one that works this way, that responds more to the geometry as opposed to the strict distance offset. Okay. Yeah. Now you'll see that the truss doesn't necessarily hit the very edge, right, of the surface, because this kind of has to do how it matches with the bottom and the surface subdivisions. So, like, there's a little bit of gap, right? But I think primarily we're using this to kind of control, like, a differential thickness across, right, the cross section of this truss in particular. Again, you have the 3, right? We're merging it, and you can feed this into the, right, the multi-pipe component, and we can again bake this. Say okay. And I'll just try to select it and bring it out again. Right, so you'll get that, right? So you can figure out kind of, you know, above or below, right? If you have any kind of panelization that works with a certain system, like, it, you know, it may not work perfectly every time, but you may be able to find, you know, panelization methods from Lunchbox or other places that actually just work well, right, with the basic quad subdivision. And just kind of, you know, you kind of have to make sure essentially that you're using either the exact same UV subdivisions or multiples. So, like, you know, for a panelization, this is 16, so you might using 32 or using 8, right? For UV divisions, you might use 8, you might use 4, you might use 12, right? Sometimes, you know, the divisions will line up, right? So kind of find those numerical relationships between, you know, how the surface is divided, and you might be able to get geometries to kind of match up well. Okay, yeah, so that's kind of the gist of this, very quick and brief.